Section 9.3 is about trig ratios in context. That will mean applications of trigonometry in more real-life situations. To begin with, we need to make sure that you've had a chance to learn these two terms, angle of elevation and angle of depression. Now, they're written inside the drawing here because this little person has a point of view in this direction. This is where their eyesight is at the horizontal level. If that person were to look up in the sky at an object, the angle that he's looking up with respect to the horizontal would be called the angle of elevation. If they were up at a higher altitude and they looked down toward an object, looking down from the horizontal, that's described as the angle of depression. Now, what we're going to have is we're going to have situations where a person might be standing down on the ground. So, the person's down here and they look up toward an object. Let's say it's an airplane. Then the angle of elevation looking up at the airplane is right here with the horizontal and that slanted line of sight right there. That's their angle of elevation. But we'll put the same situation into play here. We'll put the airplane in the sky and there's a person down on the ground and somebody up in the airplane is looking down at that person. The angle of depression to that person down on the ground is right here. This is the angle of depression. It's outside of the triangle. And this angle of depression up here is actually the same angle of elevation the person has down on the ground because the airplane is flying at this horizontal altitude and the person standing at the ground, his or her line of sight is horizontal. And if those two lines are both horizontal, then they're parallel. So those are alternate interior angles. So the angle of depression in this drawing is the same as the angle of elevation from the person down on the ground. In this hot air balloon diagram, you have a person on the ground looking up at the hot air balloon. And that means down at the ground with the horizontal line, the angle of elevation is down here. So this is going to be labeled with E. Angle E is down here. The angle of depression in this drawing is from the hot air balloon looking down towards that person. So that angle up there is considered the angle of depression. We'll put a D there. The relationship between the angle of elevation and the angle of depression is that they are congruent. And they're congruent because the horizontal lines are parallel and then those angles are alternate interior angles. If lines are parallel, then alternate interior angles are congruent. Number 4, the angle of elevation from the ground to a kite is 52 degrees, and that's already labeled in the diagram. The length of the string holding the kite is 100 feet. Determine how high the kite is flying off the ground. Round your answer to the nearest tenth. The height of the kite is labeled with an X. We will use that letter X in our setup. We are given the 52-degree angle. From there, X is the opposite side of a right triangle, and 100 is the hypotenuse. The trig ratio that incorporates opposite and hypotenuse is sine. So the setup will be sine of 52 degrees equals X over 100. Let's make a fraction on the left side and we're going to cross multiply. X equals 100 times sine 52. X is about 78.8 feet. Make sure you put the units in your answer. Number 5, a lighthouse keeper spots a boat out on the water at an angle of depression of 27 degrees. Remember, the angle of depression is outside of the triangle and it is with the horizontal. If the tower is 120 feet tall, determine the distance of the boat from the lighthouse. So let's put an X down on the horizontal leg of the right triangle. The angle that we have in the diagram is the angle of depression of 27 degrees. So you're going to have to remember that the angle of depression is congruent to the angle of elevation. So you can write 27 degrees down on that angle. Now let's set up a trig ratio. The 120 is opposite from the 27 degree angle. X is adjacent to the 27-degree angle. Which ratio incorporates opposite and adjacent? That would be tangent. So set up your trig word, tangent, then put the degree measure after the word tangent, then equals, and then your ratio. Opposite over adjacent is 120 over x. Let's make a fraction out of the left side and cross multiply. 120 equals x times tangent of 27 degrees. Tangent of 27 degrees sticks together, so I'm going to have to divide by tangent of 27 degrees to get x by itself. Cancel the entire tangent 27 degrees. Now put in your calculator 120 divided by tangent of 27 degrees. X is about 235.5 feet. Remember the units. Now we'll have to draw a picture on our own for number 6. From the top of a tower, an observer measured the angle of depression to a local park at 53 degrees. So let's draw the vertical. The person would be up here at the top of the tower. An angle of depression down to a park, down on the ground, is with the horizontal. So you have to put the 53 in here. Next, we are given the tower is 100 feet tall. Remember, we have a right triangle here, and remember that the bottom leg of the triangle is going to be parallel to the horizontal, and therefore 53-degree angle is also the measure down here. We need to know how far the park is from the base of the tower, so let's label that bottom leg with an X. Now we need a trig ratio. From the angle, we have the opposite side and we need the adjacent side. Which trig ratio deals with opposite and adjacent? That would be the tangent. So write tangent, then write the angle right after that, then an equals, and now the ratio. So your ratio should be opposite over adjacent. That would be 100 over x. Solve for x. Please do number 7 on your own. So pause the video, work that one out, then turn the video back on to check your answer. Number 8, let's draw in a line on the ground, and we have our observer out here. They're telling us the observer is 6 feet tall, so that must be important. I'm going to label the height of the person. The person is looking up at the top of the tower. She's 1,000 feet from the base of the tower. But when she looks up at the top of the tower, that's from the top of the 6 feet. So we know that that is an angle of elevation of 55.3. That's with the horizontal. So we have a different horizontal line in this picture. And the measure in here is 55.3 degrees. Now the tower's height in the triangle goes from up here down to about this spot. So this is going to be the height that we're going to calculate with our trig function. But that's not going to be the height of the tower because remember, she's looking at the top of the tower from 6 feet above the ground. And so after we find out what x is, we're going to have to add 6 feet to that to get the total height of the tower. They have given us the angle 55.3 degrees. We have the adjacent side is 1,000 and we need the opposite side. Let's use the tangent ratio. So the tangent of 55.3 equals opposite over adjacent is x over 1,000. That's not your final answer because you have to add 6 feet to that. So the final answer is 1,450.2 feet. Please try number 9 on your own. Pause the video and do the problem, then turn the video back on to check your answer. Number 10. There's an observer at the top of the lighthouse. The lighthouse is 150 feet tall. The angle of depression of two ships out in the ocean are 25 and 10 degrees. How far apart are the ships? The question also needs to point out that the two ships are in line with each other. So you can draw one triangle that goes out to one of the ships, and then draw another triangle for the other ship. So one ship is closer than the other. The angle of depression is from the horizontal up here. The first angle down to this slant line is the smaller angle of 10 degrees. The angle down to this lower slanted line is a bigger angle, and that one is 25 degrees. So all I have to do is transfer that down to the alternate interior angle. So since the 25 goes down to this hypotenuse, then this angle is 25 degrees. And the angle of depression down to this hypotenuse means that this angle is 10 degrees. I know that the lighthouse is 150 feet tall, and I need to find how far apart the ships are. So what I'm going to do is I'm going to find how far the furthest boat is, and then I'm going to find out how far the closer boat is, and then I'll subtract those answers to find out this distance right here. How far apart are the boats? The bigger triangle with the 10-degree angle, I'll call that bottom side X, and then I'll call the bottom side of the smaller triangle Y. First, I'll set up trig ratio for the big triangle. Now, the 10-degree angle has the 150 opposite from it, and I'm trying to find the adjacent side. So I will set up the tangent of 10 degrees equals 150 over X. For now, I'm going to keep 850.692 sitting there on the paper. I haven't rounded yet. I want to keep a few extra decimal places so my answer is as accurate as possible. Now I'll set up the trig ratio for the smaller triangle. Again, I have the angle 25 degrees, and opposite from it is 150, and I'm trying to find the adjacent side. So I'll set up a tangent ratio, then 25 degrees equals opposite over adjacent would be 150 divided by y. I wrote down the distance and I included a couple extra decimal places. So now for the final answer, their distance apart will be 850.692 minus 321.676, and then I'll round that answer to the nearest tenths place. I end up with 529.0 feet. Number 11. A tourist is visiting Mount Rushmore, and they're standing 500 feet from the base of the mountain. The tourist measured the angle of elevation to George Washington's chin as 45 degrees. The angle of elevation to the top of Washington's head is 48.2. How tall is George Washington's head? In order to get the height of George Washington's head, I'm going to find the whole height of the big triangle where there's a 48.2 there. Then I'll find the height of the smaller triangle that has the 45-degree angle on the left, and then I'll subtract them. Looking at 48.2 degrees, I'm given the adjacent side, and I'm trying to find the opposite. That's the tangent ratio. Set up tangent of 48.2 degrees equals x over 500. So x is going to be the whole height of the tallest triangle. Now I'll find the height of the shorter triangle. Set up tangent of 45 degrees equals y over 500. That turned out to be an exact answer. So when I subtract 559.220 minus 500, the answer is 59.2 feet.